So AP placement, it's sort of a simple term for something that I think is quite complex. It's the term that a lot of people use. Where are you going to place the AP? And most people think of it as, most non-Wi-Fi people and some Wi-Fi even think of it as something that you give to the least qualified person in the company. I've even been told, you know, we don't want you to do it. It's sort of a waste of your time. We'll just get the essentially someone equivalent to the work experience kid to do the placement of the APs. I prefer the term RF design when deciding where the APs are going to go and how many are going to be installed. It's something that's simple in theory, but I think it's the most important part of the design because it's the most expensive to fix generally. In some cases, the network won't be fixed. There might be some tweaks to make it work better. But if it's done that poorly, it could be, you know, well, depending on the size of the network, it could be a large portion of the original cost to fix it up. So this is a work experience kid putting an AP where he thinks is best. In this case, my friend Will Jones there, you can tweet him. This is where he suggested I put the AP. So yeah, there's his Twitter account. You can tell him what you think. And this is, if I wasn't in the picture, that wouldn't be too unusual. We see these sort of placements, obviously not floating there in the air, but up amongst the ductwork quite often. These are the factors that I sort of think of when I place every AP. I've got a lot of detail in this, and it's really a 1 hour talk I'm going to do in 10 minutes, so I'm not going to go through every piece of detail. And if you want to look at some of the detail, you can look at the slides later. The vendor of the AP and the model, of course, is going to be a factor. The obvious things, antenna. Is there even an external antenna model available if that's what you need? What I refer to as real enterprise, and I'm not going to name names, but what I think of as pretend enterprise for some vendors that couldn't handle the capacity of a high density or a very high density network. There's a whole bunch of tweaks that a real enterprise vendor could do, and maybe some others can't, and that's going to play into your where you're placing the APs, your cell size. The environment, is it open? The more open it is, the fewer APs you need, but then it's harder to, of course, achieve more channel reuse. Older buildings, you know, in theory they're better because we don't need as many APs, but sometimes I get to the point where I'm putting that many APs in to achieve 2 radios at 5 gig, then it's, you know, I might have to change what SNR I'm after if I don't really need as much as I'm trying to achieve when you've got, you know, crazily high attenuation walls. The age of the building, there's a whole bunch of factors of the building that will affect where you're placing them and how many. These aren't in a particular order, but they're in a rough kind of order of what I sort of what I consider. So what is the high-level application? In the past, data didn't require as high a density as voice, but now most of my data designs will work for 5 gig voice because I'm designing them. It's quite similar, apart from some of the AP placements to allow for roaming for voice, but as far as the density, I consider them fairly similar. And RTLS is, of course, a bit different in terms of the placement, or it could be. Low-level application support. What are the actual applications? What's the throughput? There's a talk from Sebastian just before talking about capacity. There's obviously a lot involved in looking at how much capacity is needed for the network. Where do you need coverage? This is what most customers and a lot of IT companies think. That's what they think of when they can't think of placing APs, just where there is the coverage needed. Of course, it's important. I like to get the customer to mark on the floor plans exactly where I want it. I don't want a list of bullet points just showing me in a complex design. It's just not, it's too ambiguous. Being able to get that information, I mean, if the customer doesn't know where they need Wi-Fi, you know, how can I know? Often I can't get it, so I've got to make a sort of a best effort guess. Redundancy, the majority of APs I place in the majority of verticals, I want 2 APs at 25 to 30 dB SNR. And of course, you're going to have a 2.4 radio, and in fact, you're going to have more than you need. But I want redundancy in almost every AP now. In the past, I tried to do it just for voice, but I think there's so many potential problems, particularly at 5 gig, with DFS channels, with lack of channel support, that I think it's almost a requirement. Outside of some corner cases, you're not going to put 2 APs in an elevator, for example. What clients do you have, and what are their capabilities? What is the maximum fire they support? When you want to do capacity planning, you need to know that, of course. How many of them support 5 gig, and how many are you going to be able to get onto the 5 gig? One of the most common problems I see now are dual band capable clients, but a significant, well, I see most networks now, BYO networks at least 80, maybe 90% of clients will support 5 gig, and half of them will be on 2.4. Whether you use a separate SSID or band steering or changing the beacon interval, or I think what's one of the most important, setting the transmit power delta, so the difference between the 2.4 and 5 gig radios to be sufficiently high that clients will prefer the 5 gig. But regardless of how you do it, you can have 90% of clients supporting 5 gig, but if half of them are on 2.4, and if you have any sort of reasonable density, there's likely to be issues. That's just an Aruba command. I think every vendor should support it, and it just shows you how many of your dual band clients are on 2.4. I think that's pretty critical, because then you know, instead of just seeing 30% of clients are on 2.4, which of those are dual band? And if you can get that number quite low, you know you've done a solid job in the design. That's with a single SSID. If you've got separate SSIDs, then it's, that's not an issue. Did I do this? No. Yes. No. Capacity, there's, I mentioned the talk before, sort of went over capacity. There's a lot involved in looking at the potential capacity. I think peak throughput is is pushed by vendors and partners more than the requirements dictate, I think. If you've got a 50,000 person stadium, the numbers I see from vendors will tell me that it did 20 terabits of data, but what's the actual peak throughput? So I'm not suggesting that gig ports, for example, or 100 meg port wouldn't be a bottleneck, but I'm sort of suggesting that you might have 10,000 clients and your peak throughput might only be 2 gigabits a second. Most clients aren't transmitting at the same time, so you still want to design it for the peak capacity, but for me, I care about what's best for the customer, and so I'm trying to ensure there's enough ensure there's enough capacity, but without, the expense going through the roof. Minimise channel reuse. Keith says it often, but it's easy to get enough signal, but trying to keep the channel reuse minimal. Obviously, as more clients support 5 gig, it's less of a problem. If we can get them onto 5 gig, channel reuse is much less an issue, but there's still a lot on 2.4, and that's where it's difficult. There's a whole lot to consider with antennas. There's some of the considerations. I won't go through them all, but there's a bunch on top of that even. Metal. It's one of the areas that I think of RF that I find most confusing, but these are some of my best practices. I try and keep metal out of the line of sight between the AP and the antenna. Maybe photo's a bit dark, but there's a lot of examples like that where the AP is placed up amongst the metal. I try to keep at least 1 meter separation between the antenna and any metal object, and don't place the antennas above the ceiling. If aesthetics are an issue, then at best place the AP, but the antenna above the ceiling, that's the one I try not to compromise on, because I think it's one of the most problematic. The height of the AP, I try to get it as close to the user as possible. Higher SNR, more airtime efficiency. Aesthetics, I think of aesthetics in 2 groups. Legitimate. For me, this is a legitimate aesthetic concern, and we'd probably all agree it's fair that the hotel wouldn't want to see the AP and the antenna. But there's so many customers where I look at the ceiling and they say, we don't want to see the AP, and it says standard office with an ugly ceiling with a dozen pieces of equipment up there. It makes no sense that they wouldn't want to see an AP. Particularly, a lot of APs, aesthetics have been taken into account. So I sort of will push back on that, but sometimes it's actually legitimate. This is an old school best practice that's been around for a while. Most of us will know this. The best practice is don't stack APs. I actually think these days it's not such a concern, particularly with more clients on 5 gig. If you're not leaving RM defaults or RM at defaults, I don't think it's as much of an issue. And in some cases, I think it can be better not to stack. Occasionally, I can't get APs into the areas I want, so I'll actually, sort of following on from the last point, I'll try and use coverage from another floor, possibly for a first AP or even a second AP coverage, to get coverage onto a floor above and below. Generally, it's in a small area. Another old school best practice, I try to not place in corridors. This is well known as well. Occasionally, I have nothing but a corridor, and if the customer wants voice, then the corridor is where I'll place it. But I still try not to. But sometimes it's not such an issue. The type of ceiling. It comes into down to aesthetics often as well. I try to mount on a drop ceiling. If you've got to move an AP and it's on a plaster ceiling, then someone's going to have to patch up the holes, or they'll just leave ugly holes in the ceiling. As I said, don't mount APs above the ceiling, or more importantly, if you need to, just mount the AP but not the antenna. This is fairly well known as well, but generally I try not to mount APs on walls. If you do, at least use dipoles or an external antenna model AP, so you can put dipoles, patch antennas, whatever's appropriate. In a small number of cases, I might actually just have an Omni, maybe plant rooms. I've had cases like that where there's just metal all throughout the plant room. The best spot is on the wall. If there's only going to be 1 or 2 maintenance guys in there, I'm not as concerned. Maybe you have to maintain the same internal model and AP. Distance to the wiring closet. Most buildings take into account the distance when they're built these days, hospitals, offices, so I generally don't even have to worry. But of course, the most common is probably a warehouse, where often the APs will be over 90 metres or 100 metres of copper length. Then you might have to look at fibre or even comms closets up in the ceiling. The physical security of the AP, you can padlock to the bracket, or it's secured in an enclosure. And mental health is one of the more common areas where they want it to be secured, not so much for theft, but for other reasons. Non-Wi-Fi interference emanating from the 2.4 and 5 gig bands. This is well known for most of us. If you perform a spectrum analysis, you're going to be able to find the sources, and if you can't mitigate them by turning off the equipment, you may be able to at least increase the distance between the AP and the interferer. Then there's still interference from non-2.4 and 5 gig bands. There's a picture of a 2.3 gig in-building repeater there, and on the right is one I did recently. It's actually a 2.65 gigahertz. It's a signal generator that's generating signal at 2.65, and there's a 5.3 gigahertz interference from a harmonic. These are not that common. I haven't come across this much, but it's still out there. There's obstructions. There's an AP that's been placed next to an obstruction. Then they've gone and done another survey and gone to put the AP in the same place, which it's almost worth... Not worth... Yeah, well, they're going to save on some cabling costs, maybe. The type of room, it's pretty obvious. Don't place it in a shower. Hospital theatres are a pain to get into. I've had a customer where the room was sprayed down and it started dissolving the APs. And anything with a Galaxy Note 7 you want to be wary of at the moment. Co-location, we don't generally place APs super close together, but if you do, maintain a distance. You'll hear 2 metres, you'll hear 3. It depends on the transmit power, the antenna gain, as to how much interference you're going to get, and the channel separation. But I've come up with 5 metres when I did some testing years ago, so that's what I try to use. What's your lowest data rate? If you really have to support 1 meg because the client has 1,000 barcode scanners from 10 years ago, then you're going to have to take that into the design. You're definitely going to have to disable some 2.4 radios unless you have a very low density of APs. Chain link fences, they can cause scattering of a 2.4 signal depending on the aperture, the space between. So if I've got a chain link fence, most commonly in a warehouse, I try to place the AP within that area to service the clients in that area, so at least the signal's not passing through. I mean, there'll be some of that with roaming, but to minimise it at least. Generally, you've got to keep the antenna from the user a certain distance, depending on the regulations. The numbers I see, 20, 30 centimetres. If you've got a very low ceiling and you're in Holland and you've got 2 metre Dutchman, then that's more of a concern. But not really for me, but for other users. Elevators, expensive and difficult to get APs, and maybe not so much difficult, but expensive. There's an example where there's a Cisco AP or Cisco antenna with an AP on the top of the elevator. And stairwells, I generally try to place them on the landing, but then you can often have regulatory problems in stairwells, at least fire stairwells. Fire sprinklers, there's regulatory minimum distances in most areas, and then there's the risk of the building burning down if you place the AP too close. That AP is too close, I think. You can find videos on YouTube that show fires going off and it shows the sprinkler pattern, and it give you an idea about how far you may need to place the AP. But I just use a rule of thumb of 1 metre, sorry. If the building's in a high density area, in other words, a central business district, I've found APs very close to the windows. You'll see higher channel utilisation, so 1 megabit frames, even from a 100 metre away building. It tends to, well, it's going to increase the channel utilisation, and I'm not sure why, but an AP 10 metres in, it seems to be much lower. I assume it's the scattering of the signal within once it hits, gets a bit further into the building. It's less of, that's really a 2.4 concern. There's a whole bunch of considerations for outdoor APs. If it's a true outdoor AP servicing a large area, then there's sort of a lot to think about. I try to keep the cabler in mind. The more difficult it is for the cabler, the more expensive, so they're going to charge the customer more. And just as an example, when I'm doing something like an office, I try to keep the APs, I try not to place them above a desk. So if you've got 100 APs, that means the cable has to interrupt those users, and there's all going to be all the debris on the desk. It's going to end up being a pain for the cabler and a pain for the user. I don't think just an AP on a floor plan in a report is enough information for a cabler to place an AP properly. All of these things I mentioned about fire sprinklers and metal. The AP on the floor plan, if that was the true size, it could come out to a 3 metre wide AP, if you understand what I'm saying. So I like to mark the ceiling, and I use my AP on a stick. Even if I'm doing a hybrid, I use my stick to place an AP on the ceiling, place a sticker rather. There's no ambiguity then where the cabler needs to place the AP. But that's not always possible. The ceiling's too high, it's a wall-mounted AP, in which case I'll just take a photo. And there may be other considerations that are specific to that site or that customer. And I add to this list over the years. So multi-user MIMO is one of the more recent ones. Perhaps the AP location is to take into account that. So this is well known from a Dilbert cartoon, but that's how I think of it. I think that AP placement is such a simple thing for customers. They think it's so simple. And as I say, I think RF design is probably a better word for that component, but I think it's expensive to fix, and it's probably one of the most complex. That is it.